All right, today we're looking at question 2004 from question number 1 from the 2004 exam. It's a rate and accumulation problem, very, very straightforward one as far as this type goes. A lot of really commonly asked questions in this. So this one and then from our packet question number 1 I think are the most basic level of this variety. We have traffic flow going through an intersection measured in cars per minute with this function. So we're looking at a 30-minute interval of time. You can see that it's periodic, and you can imagine traffic flow behaving like that. You've got kind of a clump up of cars at a red light, and then you have a lot of flow, and then light flow, and then a lot of flow, etc. To the nearest whole number, how many cars pass through the intersection over a 30-minute period? Very, very common that you get asked this question. What is the total accumulation? Total accumulation is an integral of a rate function. If you don't know what you're doing on type 1 problems, but you recognize that it says the word rate in there somewhere. Yep, there we go. The word rate. If it says rate in there, it's a safe bet that taking the integral of that function will get you some of the credit. This is a calculator active question, so we could turn to our calculator, and the calculator is going to give us a decimal answer that we'll need to round. So it's trigonometry. Make sure your calculator is in radian mode, and then you can press math 9 and integrate the function. 82 plus 4 sine of 0.5 of the variable, or variable divided by 2. I use the variable x, that's fine. 2474.077. No such thing as 0.077 cars. Well, not really, I mean sort of. So 2474 cars pass through the intersection. This part is worth 3 points. One is, did you recognize you needed to take the integral from 0 to 30, because we're looking at the first 30-minute period. The next point was having the integrand. Did you know that you were supposed to integrate the flow of traffic? And then your third point is in the answer, 2474. Is traffic flow increasing or decreasing at time 7? Give a reason for your answer. Well, if f of t represents flow and we're asking is flow increasing or decreasing, then we need to determine f prime. And specifically, they ask us at time 7. So we need to evaluate what is f prime of 7. And again, our calculator can evaluate derivatives for us. So if I press math 8, that pulls up the derivative. And I want to take the derivative of the equation 82 plus 4 sine 0.5t with respect to t, and then at time 7. So this is going to evaluate the derivative at time 7. Negative 1.872. Negative 1.872. If you took the derivative by hand, there's nothing wrong with doing derivatives by hand, except on a calculator active question, it's usually a little bit longer and more prone to mistakes. But you have to show that you found this value, which is less than 0, therefore flow is decreasing at t equals 7. The answer with the reason. Tell me the value of f prime and show that it's negative to draw your conclusion. It's only 1 point for part B. What is the average value of the traffic flow? So we're trying to find average value. Nolan?
Work it, make it, do it, makes us regular, softer, harder. Porridge, work it regular, make it softer, do it harder, makes us porridge more than hours, hours after minutes, menu made in Japan.
Okay, average value of a function, that's what's asked of us in part C. So the average function value we should recall is 1 over b minus a to b of the function. This is the general formula for average function value. In the context of our problem, they're saying the average traffic flow from time 10 to 15 So we can do this expression from time 10 to 15, and we want to evaluate that. Okay. Again, we're evaluating an integral, and it's much easier to do that with a calculator. So I've already evaluated the integral, so I can press second entry or scroll up until I find my integral. There it is. There's my integral, and edit the boundaries instead of being 0 to 30. I can have the boundaries be 10 to 15. Or you could retype it. Probably took me longer to go this way. Okay. The most common mistake here is people do the integral and then they forget to divide it by 5. So divided by 5. And we get a value of approximately 81.899. Indicate units of measure. Well, cars per minute was our flow, and we're finding the average value of that function, so it's not going to change the unit. It's still cars per minute. It's just what is the average. So 81.899 cars per minute. Since it's a rate, it can be a decimal. There is such a thing as partial cars going through intersections when it becomes a rate. This is worth 3 points. 1 point for the limits, 1 point for the integrand, and 1 point for the answer, for a total of 3 points. All right, on to part D. Part D, what is the average rate of change of traffic flow over the time 10 to 15? The average rate of change of traffic flow, the average rate of change of f of t. That's all it's asking us from time 10 to 15. So that'd be f of 15 minus f of 10 over 15 minus 10. F of 15 I can pull off of the calculator. F of 10 I can pull off the calculator. I can go through and evaluate all of those. Once you type this all into a calculator, it comes down to 1.517 or 518 if you round it. Our units on top were cars per minute, and our units on bottom was minute. So this is cars per minute, or cars per minute squared. You're talking about the slope of a rate function, so it's like, it's kind of like acceleration. I wouldn't call it acceleration, but 1 point for the answer. 1 point for the answer. And then your ninth and final point is, do you have the units right in part C and part D? So having your units right in both of those parts gives you the ninth and final point. Be sure to comment, like, and subscribe. Smash that like button. Ring the bell for notifications. Donate to my Bitcoin. Subscribe to Nolan Hahn on Instagram. Yada, yada, yada.